The ITIKZ package allows including LaTeX-generated figures in the Jupyter notebook. So here I'm importing ITIKZ, and I'm going to show how to use the Nicematrix package of LaTeX. Start with Gaussian elimination. We take a matrix A and a vector B and augment them, so I'm stacking them together. And we are going to invoke this GE function from Nicematrix and display the result. And so what we get is the matrix A augmented by the vector B. The number of right-hand sides here is simply to determine where to place the delimiter. We now proceed with our Gaussian elimination algorithm. So we define an elementary matrix E1, multiply it into A1, and so now we want to display a grid of matrices. So the first level is going to have the matrix A times B. The second level is going to show the elementary matrix and A1. And when I run this code, this is what I get. The matrix A augmented by B, multiply in the elementary matrix from the left, and we introduce the zeros that we wanted. We can annotate the matrices. So here I've added a parameter array name, so the elementary matrices will be labeled E, and the remaining matrices A and B. And when we run that, we now get the elementary matrices named E1, E2, and we show the fact that we're multiplying in those matrices from the left. Adding yet some more information to this display, I'm going to add the list of pivots at each level. So the first index here, 0, 1, 1, 1, and 2, 1, refer to the position of the matrices on the grid. So 0, 0 is missing, 0, 1 is AB, 1, 0 is E1, and 1 is E1 multiplied into AB, etc. The other thing I'm going to do is I'm going to show the basic variables and the variables, and that's simply this variable summary of variable, basic variable, and free variable, and a list of comments, one each level in this display. Running that now gives me this display. So the full Gaussian elimination algorithm, it shows the pivot decisions at each level. It has comments, pivot in 1, 1, 2, 2, and row echelon form. And it shows what the matrix products are that I'm actually putting together. There's also a QR function. So we start with our QR decomposition algorithm. And we are going to lay it out as follows. We are going to have the original vectors, v1, v2, v3, the orthonormal vectors that we get from those, w1, w2, w3, when we run Gram-Schmidt. And we are going to carry out the Gram-Schmidt procedure, which means we have to compute all the dot products, the w's with the v's, w's with the w's. The brown entries here are known zeros, zeros that we must have if we didn't make a mistake. And finally, we scale our vectors w to unit length, and we recover at this level the transpose of Q and the R matrix in the QR decomposition. What I've done here is I've added a formatter, and what the formatter does is it starts from the values of the entries, and here if you look, the values of the entries were symbols, SymPy matrix elements, and the translation into text requires those symbols to be rendered as some text expression. So the formatter that I've chosen before here is the LaTeX representation of that symbol. That's why we get these square roots. If instead I used a conversion to floating point and ask for 8 decimal figures, I'm going to get that. But that's going to be a very large display. It's not going to fit the display, and so I've introduced a scaling factor, fixed scale of 0.7, to make sure that I get the complete function. When I run this, I get the same QR decomposition, but now in floating point numbers. The two display functions that we've discussed so far are built on top of a Python class that encapsulates Nicematrix and groups of submatrices. Here, I'm setting up a computation for A times B times C in a layout that's going to consist of, in the first level, the B and C matrices, and the level below, A times B, and A times C. To render this multiplication, I'm setting up a grid layout object from these matrices, And here is a list of required calls that we're going to discuss below. And finally, we generate the LaTeX document, and we'll invoke the ITIKZ function to compile that document and render it in SVG right here in the browser. So here are some of the details of this class matrix grid layout. The constructor has some extra arguments to allow inserting extra rows and columns between the matrices in the grid. And once set up, the very next step is to invoke the array format string list function, which is simply going to specify the spacing between the various entries in the matrices. The next step to do is to take the inputs and to render them into an array of LaTeX strings. And here you see this array. The entries here are simply integers, so nothing complicated for this particular example. What we can do next, however, is we can insert some decoration on some of these elements. So there is a decorator function that allows me to wrap the entries with various LaTeX expressions. So for example, colorizing the entries in red, putting a box around them, making them boldface, and applying them to matrix 01 at the entries 00. So the first entry in matrix 01, which is the A matrix. The next optional call is to add comments at each of the levels in the matrix. So here comment 1, comment 2 in level 1 for the first set of matrices, level 2 for the second set of matrices. And what that does is it creates the position information, the color information, and the comment itself for each of those levels for a nice matrix to use. Next call is to add some information in the extra rows below. So here below matrix 1, 1, I'm going to insert an up arrow and offset by 1. So the next row down, I'm going to insert x1. And if I look at what happened in that array of text entries, it's simply written in those values in the appropriate locations. Then we need to add the delimiters for the submatrices. And what I've done in addition to that is I've added an arrow with the name of the matrix. So for matrix 02, in the position above right, I'm going to add the label A, and the label of that matrix is simply going to be done by a ITIKZ command that also got generated with the appropriate locations computed by this code. Finally, we are going to take that array of entries and we are going to make them into strings, one for each line. And so what that does is it adds the line dividers, it adds spacing between the matrices as required. Final step, we call Nicematrix LaTeX doc. It's going to insert all the required information into a LaTeX document. We are going to then call the ITIKZ function to render that document, produce an SVG, and display it in the browser. And so this is the end result. The layout of those matrices, and the decoration of one of the entries in that matrix, the name for a matrix, comments at each layer, and for the final two rows, the up arrow and the variable name that we entered for it.